Hello and welcome to the video lecture on interrupts in 8051 microcontroller. Let us first understand what is the meaning of an interrupts versus polling. A single microcontroller can serve these several devices, and there are basically two ways to do that. The first method is called as an interrupt method and the second method is called as a polling method. Now in interrupt method, whenever any peripheral device needs the service of microcontroller, the device notifies the microcontroller by sending an interrupt signal or an interrupt request. Now upon receiving that signal, the microcontroller interrupts whatever it is doing presently and it will serve that particular device. And the program which is associated with the interrupt is called as an ISR or the interrupt service routine, or it is also called as an interrupt handler. In opposite to this, in polling method, the microcontroller continuously monitors the status of the given device, and when the status condition is met, it performs the service. So after it moves on to the next device until each one is served. So that means in the polling method, the microcontroller is actually busy in serving all the devices because it is going to serve the devices in the round robin fashion. So actually the lot of time of the microcontroller get wasted in the polling method. And second important thing is that in polling method it is not possible to mask any interrupt. The microcontroller has to serve each and every device. But in case of an interrupt, we can mask the particular interrupt depending upon the priority. So this is the reason why we are going for an interrupt method, and so we'll study this interrupt method in detail in the incoming slides. Now let us first understand what is the meaning of an interrupt service routine. Now for every interrupt, there must be an interrupt service routine which is called as an ISR. So whenever any interrupt is invoked, the microcontroller runs that interrupt service routine. So the control of the microcontroller will be transferred to the interrupt service routine. And for every interrupt, there is some fixed location in the memory which holds the address of the ISR, and this group of memory locations which is set aside to hold the address of ISR is called as an interrupt vector table. Now see here, actually this is an interrupt vector table. So this interrupt vector table shows you the type of the interrupt, then the memory address for each and every interrupt. So this is what is an address of the interrupt service routine. So the meaning is, if the external hardware interrupt 0 is invoked, that is INT 0, then the address of the ISR is 0003. That means you have to write, or user has to write the interrupt service routine starting from the address 0003H. If the interrupt timer 0 is there, then in that case you have to start writing the routine at the address 000B. Similarly for INT1, the address will be 0013, timer 1 001B and 0023. So depending upon the type of the interrupt, you have to write the interrupt service routine for the corresponding interrupt at the particular addresses, and the table which holds all these addresses is called as an interrupt vector table. Also in the last column you can see that the priorities of the different interrupts are given. These are by default priorities, power on priorities. So the external hardware interrupt 0 is having the highest priority and the serial communication interrupt is having the lowest priority. But this priority you can change using one special function register which is called as the interrupt priority register, which I am going to discuss in my next videos. Now let us understand what is the steps in executing an interrupt. So let us first see this diagram. It is a easy diagrammatic representation for that. So there are variety of peripheral devices, just now I told you. Now suppose if one of the peripheral device needs the service of your microcontroller, then in that case it will first raise the interrupt signal for this controller. Then the controller what will do? Controller will finish whatever it is doing and it will save the address of the next instruction onto the stack. It also saves the current status of all the interrupts internally, but it will save on to some different place but not on the stack. Then after that, after completing this work, now microcontroller will jump to the interrupt service routine. So this ISR addresses I have already shown you in the previous slide. So depending upon the type of the interrupt generated, you have to write the interrupt service routine, and then the microcontroller will transfer the control to that particular ISR, and it will start executing the interrupt service routine. The last instruction in the interrupt service routine is a RETI instruction. So once the controller will come across this RETI instruction, it will understand that the interrupt service routine is over, and then it will come back to the main program. But from where to start, for that purpose it has to pop the content, that is address of the next instruction, which is stored in the stack. So it will pop that address and it will continue its next program or the next work. So this is what is a main program. So initially the controller is busy doing some task in the main program, and in between that this peripheral device may interrupt your microcontroller, and then this entire process will work. So this is what is a simple interrupt structure that I have explained. So the same steps I have written over here, so just go through it. And after this, let us understand what are the different 5 types of an interrupts. So there are interrupt generated from 2 timers. So we have already seen what is a timer. So whenever the timer overflows, timer 0 and timer 1, then it will generate an interrupt. So TF0 and TF1, these two are the overflow flags. So these two are responsible for generating an interrupt for these 2 timers. Then you have a external hardware interrupt 0 and 1. So that is named as an INT0 and INT1. As they are external hardware interrupt, you have to give it externally. So for this interrupt, external hardware interrupt 0, the port pin 3.2 is reserved, physical pin 3.2. And for external hardware interrupt 1, port pin 3.3 is reserved for that. And the serial communication interrupt, which may be because of the receiving interrupt flag or the transmit interrupt, that is the TI or RI. So these are the different 5 types of an interrupt. Now in my next video I am going to discuss about all the SFRs required for this interrupt process, and then we will discuss the different programs. So if you like my video, then please subscribe to my channel and share the video with your friends. Thank you guys. Thank you so much.